Everything in our world is made up of atoms. They're the simplest form of matter. Atoms contain a positive charge in the nucleus called a proton. The nucleus can also contain neutral particles called neutrons. Neutrons help keep the protons together in the nucleus because their positive charges repel one another. The number of protons actually determines which element it is. The number of neutrons can vary in an atom, but it doesn't change what element it is. Only the number of protons determines what element it is. Helium, for example, has 2 protons and 2 neutrons. Hydrogen, for example, has 1 proton, but can have 1, 2, or 3 neutrons. These are called isotopes, or equal types of hydrogen, because the number of neutrons does not change the chemical nature of the atom. So an atom with 1 proton is hydrogen. If it has 2 protons, it's helium. 6 protons, it's carbon. 8 protons, it's oxygen, so on. Surrounding the atomic nucleus is a cloud of electrons in orbit somewhat like planets going around the sun. In nature, atoms usually come with the same number of protons and electrons, so they're electrically balanced or neutral. Being neutral is an equilibrium state and also a lower energy state than being electrically charged. And we know nature likes to be in equilibrium. The outer shell of electrons is responsible for chemical interactions and for creating chemical compounds and molecules. Take an atom of oxygen, for example. Oxygen has 8 protons. It also usually has 8 electrons, and so is electrically neutral. However, those electrons have to fill seats in their orbitals like seats in a stadium. Only a certain number will fit in a given row, or what we call an orbital level. And when the row is full, the electrons have to go to the next level to find a seat. It turns out that there's room for only 2 electrons in the lowest level, so those seats get filled first. Then another row of 2 gets filled next. And the very next level, there are seats for 6 electrons, but only 4 get filled in a neutral oxygen atom. Remember, it has 8 protons and a total of 8 electrons, 2, 2, and then 4. Oxygen is in a low energy state when it's electrically neutral, but can also be in a low energy state when all of its electron seats are filled. This is another type of equilibrium. Since oxygen has 2 empty seats, it looks to fill them. Since hydrogen has only 1 proton and 1 electron, when hydrogen and oxygen meet, oxygen wants to take the hydrogen's electrons to fill an empty seat, but hydrogen wants to keep its electron. So in nature, they can agree to share the electron. If 2 hydrogens meet 1 oxygen, then the electrons from both hydrogens are shared with oxygen, filling both of oxygen's empty seats some of the time. The 2 hydrogens and 1 oxygen now bind together by sharing electrons and form a molecule, H2O, or water. Hydrogen itself is a flammable gas. Oxygen, also a flammable gas. Together, hydrogen and oxygen bind chemically together to create a new substance, water, which doesn't burn. Quite the opposite, actually. Consider another example. Sodium is a highly reactive metal. It has 1 electron in an outer shell which allows it to react easily with other things. Chlorine is a toxic substance. It has an almost full outer shell with 1 empty seat for an electron, so it actively seeks one. Sodium and chlorine can come together, like hydrogen and oxygen, to form a new substance. They bond together to share an electron and form a new substance called sodium chloride, better known as table salt. And we put that all over our food. Chemistry is just the study of how elements and compounds interact with each other. All of the substances in our world are either elements, compounds, or molecules formed from those elements, like water and salt. These compounds are made up of elements bonded together, and there's energy stored in those bonds. Certain chemicals, like trinitrotoluene or TNT, has carbon, hydrogen, nitrogen, and oxygen bonded into molecules, and if we can break those bonds, energy can be released in tremendous quantities. The interaction of elements electrically through chemical bonds produce substances that can be both beneficial and harmful. These bonds are what give rise to all of the chemical hazards we face and will be the focus of the chemistry unit.